Homework 13, section 7.1, the standard normal curve, video 7. Let's find another area. But this time, instead of to the left of a number of a z, which is directly in the chart, or to the right of a z, which is 1 minus the left area, let's find the area between two z's. For example, let's find the area between z equals -2 and z equals 1. By the way, this is the same, aka, this is the same as the probability that -2 is less than z, which is less than 1. Every area problem in a standard normal curve has a corresponding probability question. So how are we going to find the area between when all our chart tells us is the area to the left of something? Let's sketch a picture. We're still in a standard normal distribution because the variable is z, which means the center is 0. Later that will change. -2 is to the left and 1 is to the right. Now some of you might be having a minor epiphany right now. Hold off on it. I'll let the cat out of the bag at the end of this video. And we want to find this area. So how can we find this area using the z table when all our table tells us is the area to the left of something? I'll let you think about it for a second. In fact, I challenge you to pause the video and see if you can calculate the area before I do. There are two trains of thought. Train of thought number 1. I know how to find the area to the left of something, to the left of -2. I know how to find the area to the right of something, to the right of 1. And I know all of the area adds up to 1. So could I just look up both of these, add them, and then subtract it from 1? And the answer is yes. But there's a little bit easier way to do that. In fact, why don't we just chase that down? If this were left of -2, which it is, and this is to the right of 1, then the answer we're looking for is 1 minus the area to the left of -2 minus the area to the right of 1. 1 minus the area to the left of -2 minus the area to the right of 1. But how do we find the area to the right of 1? Well, left of -2. The way we find the area to the right of a number is 1 minus the area to the left. So if I did 1 minus the area left of 1 inside that second parentheses, and then I have a minus in front of a parentheses, I can distribute the negative. So now the problem becomes 1 minus the area left of -2. I'm going to lose the parentheses now. Minus 1. But this minus distributes to that minus and makes it a plus. Left of 1. And from an algebra perspective, I can combine a couple of like terms. In fact, this 1 and this -1 flat out cancel. And I'm going to write this one first because it's positive and this one second. So it's the area left of 1 minus the area left of -2. Both of which I can find in my table. So instead of looking them both up and then instead of looking up this one, looking up the one left of 1 and subtracting to find the area to the right of 1, and then subtracting them individually from 1, I could just cut right to the end and say that it's the area to the left of 1 minus the area to the left of -2, which visually makes perfect sense. If I look up 1 in the z chart, it's going to tell me the total area to the left, which is not what I want. I don't want this piece. If I look at -2, it'll tell me the area I don't want. So I can just look up both of them and then subtract. And in general, sorry, somebody was at the door. I'll be checking him out after this video. So, in short, and I could have just started with this, to find the area between two z-scores, you just look them both up and then subtract their left areas. So, let's look up both of them. Let me write in words what I just said. Look up both areas. And when I say both areas, they are both left areas. And subtract. So let's look up the area to the left of 1, because it will be the greater area, and the area to the left of -2. Let's see. All right. To the left of 1, 1.00 is right here, so 0.8413. Let me go write that down. 0.8413 minus, now let's look at the area to the left of -2. I'll have to scroll back up to the first page. Oops, other direction. Oh, that is up. All right, so -2 is here, and then 0 is the first column, so 0.228. Let's put it back over here now. 0.228. Or 0.0228, excuse me. Again, this first number is the area to the left of 1, and the second number is the area to the left of -2. So if we subtract those, I think I can do this calculator. 13 minus 8 is 5, had to borrow 1. 0, 10 minus 2 is 8, had to borrow 1. 4 becomes 3 minus 2 is 1. Looks like it's 0.8185. Let me add real quick just to make sure that that is correct, and that would be correct. So that's how you can find the area between two values on the Z chart, and the Z, excuse me, a little rattled because of the door. That's how you find the area between two Z values under a standard normal curve. Look up both areas in the chart and then just subtract them. By the way, if you had a minor epiphany earlier, it might have been this. These are 3 of the slivers in the picture for the empirical rule. So if you go back to the video where I fill in those areas and add all 3 of them, I bet it's really close to that. In fact, the empirical rule can be verified using the Z-chart by looking at the area between -1 and 1, the area between -2 and 2, and the area between -3 and 3.